So we've just had the container conversion delivered for our off-grid project that's going to Sudan. This is for a mine clearing project. I'm just going to give you a quick walk through of the conversion here and basically explain what we've got going on. So this is a standard double-ended shipping container, but it's got an internal bulkhead here with a pedestrian door. I'll show you outside that in a second. And then this container's been basically fully lined and insulated and framed out with unistrut to provide us with anchoring points and cable tucked in, provision, etc. And then the bulkhead has got penetration to the equipment that's going on the outside of it. And in here is going one of our 30 kVA, in fact, sorry, 45 kVA site grid. And the rest of the space is going to be used for transporting the solar panels, which are going to be an essential part of keeping the emissions down for this particular camp. So this is the EasyGrid that's going into the container project for Sudan, and we've just got it on a bit of a recharge at the moment. We've just done a load test on it overnight by the looks of it, and we're recharging the batteries now at something like 14 kilowatts go back into the system. This unit it's got no connectors, as you'll see, and that's because we're hardwiring it to external connection points as part of the container conversion, so that all of the access day to day is external to the insulated container. The one single connection point here is for a maintenance supply, just to keep this unit trickle charged if it was in storage close to the grid for any extended period of time. But other than that, no connections this side. I'll show you how that's going to be done in a second. We've got the lithium batteries down here. So there's 30 kilowatt hours of storage with the MG electronics, and then here are the three quattros. It's a three-phase configuration. We've got three 15 kilowatt quattros in parallel, and three-phase parallel configuration, giving us a 45 kVA machine. And then this is the other side, and as you can see, it is peppered with solar. So each of these solar charge controllers, they're all CAN enabled controllers, so they communicate over a daisy chain cable, all linking to the Victron servo unit that's going to provide both local control and monitoring, as well as the ability to track the data via the Victron website. We've got extra fusing and bus bars in there in order to accommodate the high number of solar charge controllers. And each of these solar charge controllers can accommodate around about, I think, 4 or 5 kilowatts worth of solar. So we've probably got somewhere in the region of 35-40 kilowatts worth of solar charging capacity here. And if we look down, rather than have our standard terminal blocks, rather than having our standard plug and socket arrangements for connecting the unit, we've got the terminal blocks here, and then we're going to be able to wire over that. Okay, so this is a bit of a final update on the container we're building for the UN mine clearing site out in Sudan. Just going to give you a quick run through where we're at. This is effectively the connections that are going to be made on site. We've got power in from the on-site generator, which is already there, power out back to the site, and it's going to go out through their existing distribution system. And then we've got a whole load of these kind of hearting connectors here for the various sets of solar strings. They're going to be grouped per solar charge controller, so there's an input there for each of the solar charge controllers. and each of the sets of solar panels has a local string combiner box with all the necessary protection in there that feeds down into those inputs. Each group of solar panels is going to give us around about 5 kilowatts worth of solar coming in. We've provisioned for 8. Actually, shipping with the container is enough to power up 4 of them, so we've effectively future-proofed it or put more provision in so that they can just add extra solar panels in due course. And then the final connection down here is just a pair of terminals for the auto start connection to the generator. So the EasyGrid will trigger the generator to start based either on state of charge of the batteries or load, if that exceeds what we can deliver out of the EasyGrid directly. And then I think we've seen before we were putting in the air conditioning unit, so that's all in now and up and running. We've got an e-stop. We eventually decided that we weren't going to fit a proximity switch on the door because really the door cannot be closed with everything connected and running anyway, and we just felt that it was just another thing that possibly could go wrong. So this will be the kind of on-site permanent arrangement with these doors pinned back, and then the access will be through the lockable pedestrian door. And in here we've got lighting, which is controlled by a proximity switch, the EasyGrid itself, our inside air handler. Oh, sorry, I did miss something out here on the outside. We've got our aerial here, which is for the GPS and 3G connection, so that we can monitor the installation remotely. So that's all sort of plumbed in as well. So everything then is hardwired through a bit of cable tray here on the floor into the EasyGrid. Our supply and our return air is ducted in from the air handler above in through the roof of the EasyGrid, and it's cold here in the UK at the moment, but we had this tested a couple of days ago, and it really does chuck out a lot of cold air into the unit, which is going to be necessary, obviously, in Sudan. So if we're going to come to the front of the unit, I think again on the previous little update I gave you, I explained that it's much better. Yes, it's a much barer control panel than normal, as we don't have any connection points here. If it was normally just a standalone EasyGrid, then it would all the connections would be here, but we've remoted them outside of the unit. It's currently on. We've got it configured. We're just using a standard Victron servo touch display, and that's providing all of the controls. We haven't got any particular restrictions that are forcing us to use anything more sophisticated in this particular instance. So yeah, the unit's on, and obviously we've just got it powered up so that we can do a little bit of filming and bring people a bit of an update. The unit is a 45 kVA unit. We've actually upgraded from what we bid for on this project. We bid putting in a 30 kVA unit, but felt really that although we haven't increased battery capacity, that the larger inverter capacity just gave us a little bit more headroom, as we were just really unsure of how everything's going to work out in the hot climate. But actually now in hindsight, with the air conditioning unit, we know that whatever it's like in Sudan is going to be a server room temperature inside this cabinet. And then if I ask John to rotate around, you should see starting to collect a few things that are going to get loaded in today. We've got, how many have we got? 30 solar panels going in per pallet. Yeah. So we've got 60 shipping with the system. We've got our string combiner boxes, hardware for mounting it, solar panel clips, etc. So the last job for today is to actually put some restraints in here into the remaining area. So we're just going to come unit strut some beams across against the EasyGrid, which will prevent the solar panel shifting that way. We will then constrain it at the rear here, and then we're going to ratchet strap over, putting some anchor points in the in these kind of goalpost frames. So it won't be going anywhere. So we're really quite excited. It's been getting collected this afternoon. I think all of the shipping is scheduled. It's going on board ship on Monday, so it will soon be out in Sudan. So yeah, very excited and pleased with the progress.